Hello. So if you're watching this video, it is probably because you saw a video of me finding the zeros of a polynomial function. So in this video, we're actually going backwards, where I am giving you the solution for a problem and you have to tell me what is the polynomial that it came from, okay? So we're going backwards here. Let me do one example where we actually find the solutions so it can kind of give you an idea where we're going. Let me turn on my pen because I never have my pen on. Okay. If you watch a previous video, you probably saw this polynomial already. But if I was to ask you to solve this problem, you would set it equal to 0 and you would go through and factor. You say, okay, this is going to be -7 and -1. Okay. And then you would set each one of these equal to 0. And you would solve. You get x is equal to 7 and x is equal to 1. So here are your solutions for this problem. Now we're going backwards, right? Okay, so let's say if I went backwards, right? Let's say if the situation was that they gave you x is equal to 7 and x is equal to 1, could you form the polynomial that it came from? You would have to think backwards, right? So if I have x is equal to 7, if I push everything to one side, which means I would have to actually subtract the 7, right? Look at this. If x is equal to 7 and I want to bring everything to one side, I would subtract the 7, right? And I end up getting x minus 7 is equal to 0. That's what I'm trying to do. I'm trying to get everything to one side. So what I can say, let me erase this part. The question is, what factor did x minus 7 come from? Or x equals 7 come from? I just told you the answer. It's x minus 7. Right? If I take x minus 7 and set it equal to 0, I get x is equal to 7. Right? And let's do the same thing with 1. If I was to move the 1 over, I would have to subtract it, right? And it will put everything on one side. And I get this, right? Let's erase this. So what factor did x equal 1 come from? It will be x minus 1. If you take x minus 1 and set it equal to 0, you get x is equal to 1, right? Okay, so I'm trying to find the polynomial. What I would do to find the polynomial is I would take these two factors, the x minus 7 and x minus 1, and I would put them side by side. And I'm trying to form the polynomial. So in order for me to do that, I got to get rid of these parentheses. Some of you probably already have an idea what I'm about to do here. And that is to FOIL. Distributive property, basically, right? X times x, that's x squared. X times -1, that's negative x. Then I do -7 times x. And then I do -7 times -1. That gives me +7. And then look where I'm about to go here. Let me put the x here. And then lastly, I'm going to combine my like terms in the middle. And I get x squared. -x minus 7x is -8x. And then plus 7. And look. This looks exactly like the polynomial that we started with on the other side, right? So it's like we did one way to find the solutions, and if I was to give you a solution, you're able to tell me what the polynomial is that it came from. So we're doing this on a more advanced level. So this is something just to start out. Let's go a little bit further, right? So this time I'm not going to solve the problem. I'm actually just going to give you the solutions and you're going to tell me what the polynomial came from. So let's go a little bit further. Let's say that this is a third degree polynomial. Third degree polynomial, that means you should have 3 solutions, right? At most 3. So x is equal to 3, and let's say x is equal to 2, and let's say x is equal to -5, okay? To start out, I need to know what are the binomials that these solutions came from, okay? In other words, let's shift everything to one side, right? If I was to move this 3 over, let me do it in a different color. If I was to move this 3 over, I would have to subtract it, right? And bring it to the other side. So I would end up getting x minus 3. That's what I would get if I moved everything to one side, right? Let's go to the next one. Let's say if I moved everything to one side with this 2, I would have to subtract the 2, right? And I would end up getting x minus 2. If you set x minus 2 equal to 0 and solve, you get x is equal to 2. Okay, let's look at the next one. Let me erase that part. I don't want to erase my 2 though. I can put it back. Put my 2 back there. Okay. And then lastly, if I want to move the 5, in order to move the 5, I got to actually add it, right? If I want to move the 5 over to the other side, I'm going to end up getting x plus 5. And think about that. If I take x plus 5 and set it equal to 0, then I end up getting x is equal to -5. So I know that's the binomial that it came from, okay? So now I have everything that I need. Let me clean this up. So I have all of my binomials. Look at them. I got one here. I got one here, one here. I need to find the polynomial that this came from, okay? So what I do is I have f of x equals, I'm going to set each one of these side by side on my function. Now, check your homework. Check your homework directions, because sometimes if you look at the homework, they'll accept this as the final answer. Because if you multiply all this stuff together, then technically it is the correct answer. And you can probably enter it just like this into the program that you're using, whether it be My Math Lab or Connect Math, or I'm not sure all the other ones. They have Open Math. There's a lot of different online homework systems, but check the directions and see if this is enough. If it's not, if they want to answer with no parentheses, you have to distribute, okay? And don't make a big deal out of the distributing. It's a tedious job, but it's very manageable, okay? Just do 2 binomials at a time, right? So I'm going to look at these first 2 and I'm going to multiply them together, which means I have to FOIL basically. So I take the first and the first. That's going to give me x squared. Then I do this and this, the outer, and that's going to give me -2x. Then I do the inner. That's going to give me -3x. And then I do -3 times -2. That's going to be +6. Okay, and then if I was to combine my like terms, that's going to give me x squared. In the middle, that's going to be -5x plus 6. Okay, now what I'm going to do is bring down all the other information. I have f of x equals, and I have this together multiplied now, and I also have that third binomial that I decided to wait on, right? So now I have the trinomial, the x squared minus 5x plus 6, and now I have to multiply that trinomial by the x plus 5. Again, it's something that we can handle, okay? It's just like doing the FOIL method, but now you have to distribute 3 times, right? And I'll do these in different colors so you can see each one of the stages. Let's start with black. So I'm going to take this first number and I'm going to multiply here and I'm going to multiply here. Okay, 2 different spots. So that's going to give me x to the third, and that's going to give me plus 5x squared. Okay, then I'm going to choose a different color just to keep things organized here. So I'm going to take the negative 5x and I'm going to multiply here and here, 2 spots. So that's going to be negative 5x squared and then negative 25x. Okay, and then I'm going to pick another color. Let's do, I guess we can do green. Okay, I take the green and I distribute this 6 is going to go here and here. Okay, and that's going to give me plus 6x plus 30. So now I've distributed everything that I need to distribute. The next step is to combine your like terms. Okay, I'm going to pick another color so you can see where I'm combining my like terms. Okay, and I'm going to bring down this f of x. Okay, f of x is equal to, I have x to the third. There's nothing that can combine with x to the third. I have 5x squared minus 5x squared. And that is it. And basically you got 5x squared minus 5x squared. Those cancel out. That is not always going to happen. Okay, that happened in this situation, but that's not always going to happen. And then I have here, I have negative 25 and then plus 6. So negative 25 plus 6, that's going to be negative 19. And then I have the plus 30 that doesn't have anything to combine with. So this would be the polynomial. This is the polynomial that the solutions 3, 2, and negative 5 came from. Okay? Let's do it again. See, that wasn't too bad. I'm telling y'all, it's not that bad. I hope not. I hope it's not that bad. Okay. Let's do one more, okay? Let's try a 4th degree polynomial. A 4th degree polynomial, okay? So how many solutions? That's 4 different x values, right? So x is equal to 2, and let's say x is equal to negative 3, and let's throw in some i's, some complex numbers, right? You know I have to throw a little twist in here. Like, why do we have to do this so soon? Yeah, we have to do this. Okay, so let's find all the binomials that these solutions came from, right? Remember, you got to move everything to one side. So if I was to do that, let me change the color here so you can see what I'm doing. For the first one, I have x equals 2. Now, if I was to move the 2 over, I was about to add it, and I should not add it, I should subtract it, right? So that's going to be x minus 2 for the first one, okay? And now let's look at the next one. In order to move this, I have to add the 3. So that's going to be x plus 3 to move it to the other side. And then the next one has i's in it, but your procedure doesn't change just because you have a imaginary number there, right? So you're still going to move the 3 over by subtracting it. You're just going to subtract 3i now, okay? So this is going to be x minus 3i. Same procedure. And same thing is going to be true with the negative 3i. In order to move that, I have to do plus 3i plus 3i. Okay, so that's going to be x plus 3i. Okay, and look how many factors I have. I have 4 different factors. Now I have to basically put these all together in a polynomial, and yeah, you guessed it, I'm gonna have to multiply all this stuff together. Let's change color here because I don't want all this to be written in red. So f of x equals, it's going to be x minus 2, x plus 3, x minus 3i, x plus 3i. Okay? All right, so I want to make a comment about two things. First, again, check your directions. When you're working these problems out, you may be done if you do this. You may be done at this step right here, okay? If you're not, if they say, hey, we don't want parentheses, then you're going to have to multiply all this through. So that's one thing. The second thing is, notice how I lined up everything. The two factors that had i's in them, I put them side by side. This is very important. I have a 3 and I have a minus 3, and I put those two factors, the x minus 3i and the x plus 3i, I put them side by side. It's very important that you keep those together, because in order to get rid of all these parentheses, what I'm going to do first, let me change color. What I'm going to do first is multiply the two numbers that don't have an I. I'm going to multiply those together first. And then after I multiply those two together, I'm going to multiply the two that have an I. I'm going to multiply those two together. Okay? I always tell my students, complex numbers have I's in them. Think you got two I's and your two I's are side by side. You need them to be side by side. Okay? Because when you multiply the two complex numbers together, the i's should disappear. Okay, so let's slowly work through this and see if we can make it happen. Okay, I'm going to multiply the first two together and see what happens. So this is going to be just simple foiling here. This is going to be x squared plus 3x. And then I distribute the negative 2. That's going to be negative 2x. And then there'll be minus 6. And if I was to go ahead and combine my like terms, I get x squared plus x minus 6. Okay? Just want to bring everything down. Okay, now I'm going to multiply the two i's. Remember, two i's side by side. I'm going to multiply the two i's together. And when you multiply, when you go through and you do your FOIL method with anything that has an I in it, the I should disappear. Okay, so let's try this and see what happens. I have x. I'll do this in a different color again to kind of keep things separated here. So I have x times x. Okay, that's simple enough. That's going to be x squared. I have x times 3i. That's going to be 3xi. All of those, it's like multiplying three variables together. Just put them all side by side. 3xi. Then I'm going to take the negative 3i and I'm going to multiply times the x. That's going to be minus 3xi. Just put them all side by side. I usually put the I all the way at the end. Sometimes you may see the I right after the 3, and that's fine. It's the same thing, okay? And then I have negative 3i times positive 3i. So let's slow down for a minute. I have negative 3i, and I'm actually going to write it over here in the corner. I have negative 3i times 3i, okay? First of all, you multiply the numbers together. Negative 3 times 3, that's going to be negative 9, right? And then you multiply the i's together. I times I. I times I is I squared. Just how when you do x's, x times x is x squared. I times I is I squared. A little trick here. I squared is equal to negative 1. Always, always. This is very, very important that you understand this. I squared is always going to be equal to negative 1. This is a property. This is a rule from learning your complex numbers. Just know that when you have I squared, never leave that in your problem. It's always going to be replaced by a negative 1. So let's put this 9i squared here. But know that I'm going to take that I squared out and I'm going to put -1 in its place. So watch on my next step when I simplify everything. Okay. Do this in green. All right. So I have x squared. I got x squared. I got 3xi minus 3xi. They basically cancel each other out because one is positive, one is negative, right? And then I have -9i squared. Now, what did we say about I squared? I squared is equal to -1. So if I have -9 and then I'm taking the I squared out and I'm putting in -1, what does that give you? That gives you -9 times -1. -9 times -1, that turns into a +9. So really what my students memorize is they say, oh, when you see I squared, just basically change the sign. That's basically what you're doing every time. Okay, let's move on because that took a lot of explaining, but it's a video. Rewind it, watch it again. You know, we can do that. I think there's even a function to slow down when I'm talking. Can you do that? I'm not sure. Okay. I'm not done yet because I still have parentheses. Now I have to multiply the first part times the last part. Okay, let's do x squared times x squared. That's going to be x to the 4th. I'm actually going to move this down a little bit so I can get more room. X squared times x squared, that's x to the 4th. X squared times 9, that's going to give me 9x squared. Then I go to the next number, right? Let's do this in a different color. Let's do x times x squared. That's going to be x to the 3rd. And let's do x times 9. That's going to be 9x. Then let's go to a different one. Let's go blue. I have -6 times x squared. That's -6x squared. And then I have -6 times 9. That's -54. And all the parentheses are gone. We're almost done. Stick with me, we're almost done. Okay, now I gotta combine my like terms. This is the last step, combining your like terms. I have x to the 4th. Nothing combines there. I'm going to put these in descending order. So I have x to the 4th. Let's do plus x to the 3rd because there's nothing to combine there. Then I have 9x squared minus 6x squared. So 9 minus 6, that's going to give me +3x squared. And then I have this 9x that doesn't combine with anything. And then I have the 54. And now we can take a deep breath because we're done. Okay? We're done. Namaste. Like I said, it's like a distribution party. Because really, once you get everything set up, I think the hardest part is just understanding how to distribute. Okay, I have time. I want to do one more example just to show you the variety that you can have here. I want to do one more example. So let's say you have a problem with your screen. Okay, let's say you have a 4th degree. Let's say you have a 4th degree polynomial, and look what happens here. So you have this problem that says you have a 4th degree polynomial. So in your head, you got four x's, right? And this is what they give you. They say x equals to -5, but has a multiplicity of 2, okay? And then they tell you x is equal to -3 minus 2i. And then that's all they give you. You should instantly have questions because you only see 2 x values, but they're telling you that it's a 4th degree polynomial. There's a problem here. You should have 4 x's lined up, right? So let's talk about what's going on here. First of all, if they give you a value, x equals -5, which they did right here, x equals -5, and then they go on to say that the multiplicity is 2, what they're telling you is that that number is seen twice. Because it has a multiplicity of 2, that means -5 should be listed 2 times. So if you saw one that said you have a multiplicity of 3, you should write it 3 times. Multiplicity basically tells you how many times it's being repeated. So if I was to rewrite this, it would be, okay, since the multiplicity is 2, it should be written 2 times. I have x equals -5 and x is equal to -5. I should see it twice because they said the multiplicity is 2. If you have no idea what multiplicity is, I have a video talking about polynomial functions. You can go look at that and they'll kind of describe what multiplicity is. But really all you need to know is that it's repeated however many times the number says. Secondly, you have a complex number, a number that has an I in it. And you remember when you have an I, you know what I told you that my students, when they think about I's, they think about complex numbers and having I's. You have 2 I's. You only have 1 I listed right here, so you're missing one of your I's. You should always have the opposite I of what you see here. So you have 1 0. Look at this. You have one of your zeros. That's the one that they gave you. But you actually need to also include the conjugate of that one as well. And the conjugate is basically just changing the sign of your I value. If you remember from the previous problem, we had 3i and we had -3i. Look here, I have -2i, so I need to also have a +2i. So just make sure. And when I made those changes, now I have, look, I have all 4 of my x values that I was looking for, okay? So I had to have that little conversation before we start. The conversation took longer than me just writing it down, right? So you could see something like this and just know this is what you do. You have all 4. If you see multiplicity, you write it the number of times that you have it. If they give you a complex, just make sure you have its conjugate as well. And conjugate is just doing the opposite of the I value, the imaginary value. So I have all 4. So let's write our factors, right? Okay, so first of all, for the first one, let me change color. Okay, for the first one, I got to add 5. So that's going to be x plus 5. And since the next one is the exact same number, it should be the exact same polynomial. Okay. The next one should also be x plus 5 because you add the 5 to bring it to the other side, right? All right. So now these problems at the bottom, they look complicated, but remember you're just pushing everything to one side. So if I was to move the 3 over, I would add the 3, and then I need to also have some room here. I don't have enough room, so I'm going to write it over here, and that is okay, because I'm not going to squeeze all this in one space and then you not understand what I'm doing. Okay, so if I want to move everything to one side, I need to add the 3, right? Add the 3, and that's going to give you x plus 3 is equal to -2i, right? But now I need to also move the 2i. So I add the 2i. And so what I end up getting is x plus 3 plus 2i equals 0. So I have 2 things that I need to move over to the other side. I had to move the 3 by adding it, and then I had to move the -2i by adding it as well. And this is the factor that I get. So when you look at this one right here, I'm going to erase this. Okay. When you look at this one, it should be x plus 3 plus 2i. Based on what we just wrote, right? So the next one would be what? You got to move the 3, and then what else you got to do? You got to subtract the 2i. subtract the 2i. So this one would be x plus 3 minus 2i. Okay. Okay, so the next step is to now let's take all of these factors and line them up side by side, right? So I have f of x equals x plus 5, x plus 5, and then remember the 2 i's. You got 2 i's and you want them to be side by side. So I'm going to make sure I line these two factors that have i's in them. I'm going to line them up side by side. Now, also, there's some programs, homework programs, that say they're okay with the parentheses as long as they don't see any i's. So there's some programs that say just get rid of the complex numbers. So if you multiply the two complex numbers together, the two parentheses that have the i's in them, if you multiply those two together, then you can be finished and keep the other two parentheses. But you know, I'm just trying to give you all the options, you know, because I know people get frustrated with online homework. But always ask your instructor too. Don't struggle through it alone. But okay, now we need to get rid of all these parentheses if the program tells you that you need to do that. And if you remember what I said earlier, you're going to multiply the two that don't have the parentheses or don't have the i's. If they don't have the i's, you multiply those together. And then after you do that, you're going to take the two that have the i's and then multiply those together. Okay? And you're not always going to have two. I want to point this out also. Like the way I have two right here that I can multiply together, sometimes you just have one. Okay? Sometimes you just have x plus 5 and that you don't have anything to multiply in the beginning. So don't be thrown off if you don't see two sets of parentheses that you can multiply together that don't have an I. That's not always going to happen. So let's multiply these together. This would be x squared, because I multiply here, here. Then I multiply here. That's going to be 5x. Then I multiply here. That's going to be 5x. And then I multiply here. That's going to be 25. Okay? And I want to combine my like terms. So that's going to be x squared plus, no, not 25. 5 plus 5 is 10. 10x plus 25. Okay. So that's the first two multiplied together. I got x squared plus 10x plus 25. Now let's multiply these i's together. And let's just take our sweet little time. Because I want you to understand. Okay, let's do this in colors. I'll do the first one in green. So I'm going to take this first term x and multiply to the first term in the next parenthesis. That's going to be x squared. Then I take x times 3. That's going to be 3x. Then I do x times negative 2. That's negative 2xi. You can just put that all together. Okay? I'm going to switch colors. Let's go to blue. Okay? And I'm going to go across the top this time. So I'm going to take the next term, which is 3, and I multiply here. First term here, that's going to be 3x. And then I have 3 times 3. That's going to be 9. And then I have 3 times negative 2i. That's negative 6i. Okay. And then I'm going to change colors again. Let me do, I guess, red. All right. Now let's take 2i and distribute. So 2i goes to the first term here. That's going to be 2xi. Then I take 2i and distribute it to the 3. That's going to be 6i, positive 6i. And then I take 2i and I multiply by negative 2i. Okay, so let's have our conversation. I have 2i times negative 2i. That's going to be negative 4, and then I times I is I squared. So negative 4i squared is what I got when I multiplied those two. And remember what I squared is equal to. Let's not forget that. I squared is equal to negative 1. And we'll come back to that in a minute. So look at all of this stuff. Let's combine our like terms. We got it. We got it. We got it. Combine your like terms. Okay, so this is going to be x squared. I have, what do I have here? I have 3x plus 3x. That's going to give me 6x. 6x. Then let's look at these i's. I have negative 2xi right here. And then I have plus 2xi. So I have negative 2 plus 2. They cancel out. They go away. And look what also goes away. I have negative 6i plus 6i. Look, they go away. That is going to happen every single time. Your i's should cancel out. Okay? Make your life a little bit easier. And then I have a 9, but over here I have a negative 4i squared. What did we say I squared was equal to? We said it was equal to negative 1. So what's negative 4 times negative 1? That's going to give you positive 4 when you multiply them together. So what am I combining here? 9 plus 4. That's going to give you 13. Okay. Rewind this little part if you need to see this again. Okay. If you don't accept this, rewind it, look at it again, like make it make sense, ask questions. Okay. Last little part, now I have to multiply these two sets of parentheses together, and we can do that. I'm going to do x squared times x squared, that's x to the 4th. I have x squared times 6, x, that's 6x to the 3rd. And then I have x squared plus or times 13. So that's plus 13x squared. And then I have, let me change colors so you can see how I'm doing this. I have 10x squared times x squared. 10x times x squared. So that's 10x to the 3rd. 10x times 6x. That's going to be 60x squared. Okay. I have 10x times 13. That is 130x. Okay. Change colors again. What do I want now? Blue? Okay. Let's do 25. 25 times x squared. That's 25x squared. 25 times 6x. What's that? 150? 150, right? That's 6/4, okay? And then 25 times 13, because I'm not gonna just guess on that. It'll be 250 plus 75. So what would it be? 325? Ah, look, 325. That mental math, man. 325. Okay. Woo. So got all the parentheses out of the way. Now I just need to combine my like terms. I'm almost done, y'all. Okay. Y'all, I did not make this up. This is math. I didn't make this up. Please don't be mad at me, because this seems like a lot of work. So you got 6x to the third and 10x to the third. You're going to add those together and get 16x to the third. I have 13 plus 60 plus 25. 13 plus 60 plus 25. 13 plus 60 plus 13 plus 60 plus 25. 98. So that's 98 x squared. And then I have, what else I have? 130x plus 150x. That's 280. 280x. And then all the way at the end, I had that 325. And here we have our lovely answer. Thank you for watching. Just be patient with yourself. This last one was probably the most difficult one you will see, okay? But, you know, rewatch the video, ask questions if you have any, and until next time, see ya.